Okay, so let's kick off our session. And as fun today, we are going to learn method references, building on top of what we had covered yesterday on how to use Lambda expression. Today is going to be like a more practical application of Lambda expressions. And we are also going to be taking Lambda expressions and even a step forward by transforming them into even something else, right? So what you're going to do first is we are going to make sure we have an idea of a topic called Stream API or Streams in Java. And then once we understand that, we are going to apply the knowledge on streams to Lambda expressions, and then we are going to even improve the way Lambda expressions are written using method references. So all these things we are doing here, all of the things that we are going to be trying to do here are simply a way to improve the way our code is written, increasing the readability, and also making sure that our code is simpler than it was before without using Lambda expressions and method references. So now let's start with the Stream API. I'm just going to give you a small overview on how streams work, and building on that understanding on how streams and what streams mean, we are going to easily understand what you're going to be learning forward. But I highly encourage you to do a deeper research and get used to how streams work. So starting with streams, I bet you understand that whenever we say stream, there is a word stream. And let's start by understanding what the word stream means. What is a stream? Like in real life, in normal life. What do you understand when we say a stream? Yes? Hmm? Oh, yes. Oh, yeah. Live video streaming. Oh, okay, you understood streaming. Okay, like now, I see before the coming of internet, before people had internet and computers, when someone was maybe saying, I'm sitting nearby a stream, maybe of the river, you understand what a stream is? A stream is like, but you know what a river is, right? A river looks like this, right? It's something that flows, right? A stream is like a continuous flow of water in a river. And if you add to the logic of streaming, you now understand a continuous show like for video online, right? So this is what someone who would come in maybe 1950 would think of if we say the stream. But today when we say a stream, we understand something different, right? Okay, so let's say this is our river, right? And do you know what a dam is? Let me hope no one is just thinking of dam, right? A dam like this, or something like this, right? Yes. Or you know also what we call like a waterfall, right? So let's say our river flows like this, and then all of a sudden it gets to a point it falls down, and then it continues, right? And then maybe there is a dam somewhere here. Okay, so now that you understand it, I feel like we are now starting to get the idea of where the term stream API came in Java, right? This stream is used when you have, let's say, a collection of data, right? Now we have so many data, right? And we want to do things on those data. And we want to do it in a more simplified way. And one thing you need to understand on streams, they go one way, just like a river. A river doesn't go back. They go one way. So, for example, I bet you know what irrigation is, right? Or you have also understand what a dam is. You could say, for example, I want to, let's say, let me make a river. Let me draw a long river. So let's say this is our river, right? And then you create some breakpoints, right? Let's say maybe you want to filter a river or you want to clean a river. Let's say here in Rwanda we have Nyabarongo, like, and you know that Nyabarongo is very dirty, right? But at the point, there is a point where you reach and Nyabarongo is clean. I don't know if that happened, but there are rivers that you have in Rwanda. According to where they pass, the water looks yellow or dirty, right? But as they move through the mountains, you end up seeing a clean river, right? So let's assume there are people who are filtering the river, but that's not the way it is, right? So let's say you put a filtration maybe point here to clean the river, and then here you put another one, and then here you put another one. And then at the end of the day, you're going to get different water from what you had here, right? And another example, I don't know if you learned in maybe something in primary, filtering water, right? You had the bottle, then here you put maybe sand, another layer you put charcoal, another layer you put things like that. Do you remember? You just pour water to the top, and as it goes through, from the top to the bottom, the water is being purified, right? So it also goes in a one-way stream, right? And now, having understood all these, now let's look at how streams work in Java. So in Java, let's say you have a collection of data. Sorry, let me close this one. So let's say you have a collection of data and let me say it's a list of some integers, right? And let me call them numbers and say I'm going to define it as an array dot as list. Then provide the list here. Sorry, what am I like this? 1, 2, 3, 4, 5 arrays. I need to also import it here. But let me transgress a little bit. I want to know if you remember numbers 2 list that all. What is the difference between the following things, the following ways of defining a list? Let's start from here. Anyone with an idea? Anyone? You're not the same. Okay. So I guess we all know that when you're using the list of, you can't modify it. Someone has connected to my Wi-Fi. So yeah, let's come back. So when you're using the list of, you can't modify anything. So this is what we call immutable list. Immutable list. And you're going to understand this term a lot when you're going to be doing programming stuff. Something called immutability, mutating data, and stuff like that. So when you're saying mutating is changing, and you know, I guess you watch the movies, things we call mutants, someone mutating, get that? So that's the same logic, something transforming into something else, right? So this list here, when you're using list of, you cannot modify anything. It is an immutable list. But the reason why we choose now to use arrays.as list, this one is a mutable, it's a mutable list. A mutable list, right? So for our scenario, let's say this was our stream, this was our river, and we want to make sure that on these numbers, we want to get the, let me say, for each number, we go through each number and we multiply it by 2, right? So you understand that you're going to have to modify these numbers. And if you're using an immutable list, it's not going to work because it can't change, right? So we need to use a mutable list. So that was like something to make sure you know of. So let's continue. So now let's use Stream API. So here I'm going to create a variable which is going to hold my doubled numbers. Then it is, I'm going to say numbers dot stream, right? And now here, after defining the stream, I'm going to say what is going to be happening, right? So you can have as many steps as you can, right? So for example, here, I'm going to come here and put a dot. It is also similar as if I would come here by them. So understand if I put a dot here is the same as I would write dot. Maybe let me say I want to, let me say, filter through the list, right? So let me put it down here. So for now, all we want is to simply map through the list. Mapping is like another way of looking through something and then do something about each element or each item of the list, right? So let me use the map. And then now we are going to apply the lambda expressions, right? So yesterday we've seen that lambda expressions have two parts. There is the part here where we put parameters, let me say, and then another one where you put maybe the expression, right? So this one is like the body of method, and this is like the part where we put the parameters. So we are now going to immediately, we are going to look through each element from these numbers, right? And on each element, they're going to give us that element they're going to give us, we're going to take it as a parameter, right? So ideally, you would write it like this, right? And then here you're going to provide the body of whatever you want to do. So ideally, this is how it should look like, right? So here I'm going to put maybe n as the number, and here I put the body of what I want to do, right? So let me say here, I want to take that number and multiply it by 2, right? So this is how it should look like, but this is not an ideal way of writing this, simply because you don't really need these open brackets and closing brackets if it is on one single line. So I'm removing them, right? And since I only have one parameter, I don't even need just these brackets as well, right? So let me remove the brackets as well. And then the next thing I'm going to do, as you can see, mapping, you just look through something, do something. Like, I mean, you look through a collection of items and do something about them. but that's it, right? It doesn't do anything else. So now we want to collect, right? Everything, every single item that it has looked through, right? And return it to our variable we defined here, right? So it has looked through all the items, and now we're going to collect them, and so that we can use those data. So we're going to use dot collect, and let's say collectors dot to list. All the information we've gone through, we're going to return it back into a list that can be used here. So just for now, let's look at what we would see if we look through this data like this. So let's put system out.println and put our doubled numbers. Remember, the numbers are this one, so we expect doubled numbers. And here we are, 2, 4, 6, 10, right? So our numbers are double. But this is not the only thing you can do on using streams. You can even, for example, let's say you can, let's create a stream to filter maybe even numbers, right? Let's say list integer even numbers dot stream again, then dot really dot filter. And now I'm going to filter through each item, right? Again, we're going to use lambda expressions. Here I'm going to, if I look through these numbers, every number they are going to be giving me that number, right? I'm going to be checking if that number is divisible by 2. And if it is divisible by 2, I should get a remainder of 0, right? So I should put double equal, right? After looping through those numbers, then I need to collect those numbers that fulfill the condition using collectors dot to list, because I just need a list of those numbers. And in this scenario, if I try to list those numbers, I would get something looking like even numbers, right? So here I'm going to get the even numbers. So let me run again. And here we have the doubled list and the list of even numbers on, right? So there is something you can even sort, right? You can sort, let's say you have, let's try with sorting. Let's create a list of names, right? And you're going to be mixing those names. List, strings, names, arrays as list. Tell me the names that I should put in the list. Anne, Chanel, Gajo, Hope, Aline, Esho, Alice, everybody, and Alice, right? So as you can see, these names are arranged in Like there is no order in the way they are arranged, right? So we are going to use streams again. So let me create a stream, a list that is going to hold the names that are arranged on, let me say, is it ascending order? Yeah, on ascending order. Streaming, yeah, that's what you are going to see. Okay, so we're going to say again names dot stream, right? Then dot sorted. Okay. So we're going to be having a two inputs, previous and the second at the yes. Why do you think that it comes to which one? How do you know which one to do? Okay, you have to sort it. Let me check. Sorted one which uses comparators, and these comparators, you remember that we were using them yesterday, right? Okay, so let me check which one to use. Let's try them all. By the way, which one do you know even if they choose the comparator or the one without comparators? Let me check well. Did you use comparator yesterday? I don't think so. Yeah, here it is. When you use sorted, just sorted, they just sort them and there is nothing else you want to do, right? Just sorting, right? So we're going to look at two different examples. Then after sorting, of course, you need to collect whatever it is we sorted, right? And say to list, right? So this is one way. And let's see the output first. Sorted list. Arrange the names. Oh, sorry. This should be a class. Allow me to comment these ones here. So I guess you can see that all the names here are arranged, right? But if you want to reverse the order now, yes. If these are starting from A, B, C, D, you know, ascending order. Now I want to start with descending order, right? So this is where now you start using collectors. I mean, comparator. Is it comparator or comparator? Yeah. So here, let me even say this is a sorted list ascending order. And now let's use the same example, but put them in descending order. This is where now we start saying comparator dot reverse order, right? And I guess you can see that there are even so many other things you can do, right? There's so many things you can do here. And then we get our list. Arrange the names. Sorry. So this should be arranged names. So we're going to get two different lists, one with ascending order and another one on descending order. So here we are, right? So you can see that I guess now you have a little bit of an idea of what streams are, like what you mean when you're dealing with streams, right? Just whenever we say a stream, remember a river with different breakpoints, where on each breakpoint you can do something. So to this list we've been seeing here, we've been only seeing like only one level, right? I want to find an example where you can have different levels of modification, right? For example, here, let me say, yeah, another interesting example. We're going to be sorting the names, right? And then below, we capitalize them. We're going to be sorting the names, and then below we use the map, and then we capitalize those names, right? So name dot to uppercase, right? So the list we are going to get here is going to be a list of sorted and capitalized names. Yes, it is going to capitalize all the names, because there is no special condition. Right, so you see that all the names are sorted and capitalized, right? And still you can even add another, another implementation you want here. For example, you could here come and filter them, right? The one who are maybe, let's look at how long they are by. Let's just get the names with only 4 characters. You're going to help me on this. So dot filter. And then for each name we have, right? So we're going to be checking if the length of the name dot length. For strings, we use length or length, right? Equals to, 4, right? So then you understand here, we're going to get arranged names on ascending order, which are capitalized and are 4 digits of 4 characters long, right? So I guess you can see the only list we have, right? So isn't life easy? Very easy with strings, right? But if you had to use the normal for loop, then you put conditions, how would it look like? Ugly, right? But this is very, let me say, this is clear. Once you understand how to use strings, this becomes like a very good way to write clean code, right? But still, I guess you can see that we still have some warnings. And this is the topic of today, right? There is even another way you can even simplify this code, right? Okay, so before we can start simplifying it, now let's go back to the topic of today, right? After understanding how it works, then you're going to come back here. But let me hope there is no, like, streams are understandable. If you have a question on streams, please let me know before we can continue. Yes. Yes, I probably deleted it. There is two parts, right? This part and this part here, right? Oh, okay. So with streams, right? Of course, you're going to see in the next part of what you're going to discuss, and you're going to see how you can use system out and stuff like that. But in streams, remember, a stream is the river. Let's say it's a river. All you want is to be modifying something on the data as we move on. You get the point? Or think of the way in a factory things work. There is someone who is going to maybe create something, and another one is going to package, and then another one is going to put maybe a sticker, and another one is going, and so on, right? We are not displaying here. We're just making some modification on that continuous flow of information or data, right? When we reach to the end, that's when we collect everything we produce, package it in something using a collect, right? And then we get the output here. You get it? That's the logic of streams. We are just doing some few modification on the data as we move forward. You get the point? Oh, removing the brackets here. We just remove them because they are not really needed since it's only one parameter. If you have two parameters, it would definitely make sense, right? But simply since it is just one parameter, we don't really need to put them there. That's the only reason. But here, definitely you would get an error. Sorry. Really? Okay, let me put it like this, and this is going to give you troubles, right? The only thing you're allowed to do here, you can put the parentheses or not. That's fine, right? But you can even, if you feel like you want to put these brackets here, or if you want to do many things, you don't just want to transform these characters to uppercase. Maybe you want to also add another digit, right? This is when you are going to definitely need to open a bracket and then close it. And of course, you're going to have to put this semicolon, but this thing seems like this implementation is not correct. Let me try to do something on the name and see what I will get. Name plus. Okay, I'm going to check on this. But for now, we are going to stick with removing the brackets, the curly brackets on the expression part, right? Yes. map and you're saying they kind of do the same thing? If you're using map, you cannot add other things. Is asking if maps can do are maybe kind of similar to streams. So let's do it here. So look at what would happen if you're just using a map only. Modify the names. So let's use maps to modify these names, right? Because the way we familiar with maps, you'd have the name here, and then you start, by the way, let me hope I'm writing it correctly. No candidates found for method. Let me hope I'm writing it correctly. I'm using maps properly. Really, this is not what I want. How would we use maps to look through these names, by the way, if you're not using streams? So we continue, okay? So let's say we want to capitalize the name dot to uppercase. It's not even coming. Oh yeah. Name dot. So it doesn't work. There is something wrong. I think so. Let's just find an example of this simply using map, if you can find it. Does this make sense? Yeah, maps. When you're using maps, you're not going to modify anything on a map when you're using a map, right? But when you want to try to do some modifications, you need to use a stream so that normally using a map, you just, how did you say it actually? Yes.
It's only for creating like a brand line for like for a new sequence for us to easily to transform the
Definitely. As you said, the stream is here just to create a pipeline, for us to go through the information, right? And then as we are going to go through the information, as they are going to be passing, we are just going to be making the modifications we want, right? Okay. So something else, let me see. And before we can leave here, if there is no other question, Is there any other question before? Yes. Reduce. An example of using reduce. Okay, so reduce is when you want to, let me look for use cases of reduce. Reduce, you often want to modify also an array. Is it an array or a collection of data and get one output, right? So let's look for a practical example. Who can come up with a practical example on using reduce? Yeah, having an array and then you add all the elements of it. Okay. Shall we continue? Hello? Shall we continue? Okay, so here we are. I'm just going to create a list of integers. And I want to look through arrays as list, these numbers, and add them all together and get their sum. So already I've used numbers. Let me use something else. Let me say grades. And then I'm going to, of course, use the string int sum. It's going to be numbers, now grades, dot stream. And then I use reduce. So if you can come here and hover here, okay, let me go back a little bit. They are going to give us the documentation on how to use reduce. But this documentation is not clear. Okay, so reduce often has two parts, right? There is we call it the accumulator, right? And yeah, so are you understanding? We're explaining you. Here we are going to use reduce to sum up all these numbers and return the sum of these numbers. Understand? So here we have just initialized a new variable which is going to hold our sum, and we use stream to look through, to go through the data, right? Reduce has two parts. One is what you call the accumulator, or the data we start with, right? And then here, we provide the first and the second element through our stream. Let's say A and B. And the first and second main element, for example, is going to be 1 and 2, right? So you're starting at 0, and you're going to take 1 and 2 and add them. So you're going to say A plus B, right? After adding 1 and 2, here we're going to get maybe 3, right? And then we take the next numbers, Are we going to take 2 and 3 or 3 and 4? 3 and 4, right? No, it's not correct. No, we're going to take the accumulator and add the sum we're going to get here. Right? Okay, let me repeat it. This is the, let's say, the starting value we have 0 plus the sum of A1 and 2. Or if I'm saying it right, right? So we say, but that is not correct. I feel like I'm saying it wrong. Whatever we get. Yes.
And then it will also take, it will take 0% in one, so the identity will come one and it will go like looping.
Yes.
The loop will be the number in.
Yeah, that's correct. Let me just do as let me try to find a way to simplify it. So here is the part we want to understand, right? So, sorry. Oh, come on. Initially, we are going to start by 0, right? Then here we're going to be having 0 and 1, right? And then we say 0 plus 1 is going to be 1, right? So our accumulator here is going to be 1, right? So we come back here. By the way, remember that here there are parentheses. Is it brackets or parentheses? Brackets, yeah. Or both of them. Yes. So now here we have 1. Then we're going to say 1 and 2. 1 plus 2. Then we get 3. 3. By the way, let me hope we are not confusing things. This should, this is correct, right? So we are going to take these 3, which we are putting here, and add 3. Yes. And then 3 plus 3, right? And we get 6. Then 6 plus 4 is what we're going to do here. And let's finally have 10 plus 5. So the output you're going to get from this reduce is going to be the last value you're going to get to. Does it make sense? If you wanted to display the sum, then you put it here. The sum is 15. Great. So now let's question? Yes. There you have to use maybe the for loop, right? But there you're going to be writing the implementation inside the loop. Yeah, it is going to be bigger than what we have here. And I bet you have already seen, I bet you have been using for each loop, right? And that was the first use of lambda expressions, even though we were not learning lambda expression. Yes. Oh, reduce, don't understand it as a reducing. That's, yeah, it can be confusing, but reducer, like it reduces everything you had to one value. That is what it means. You have so many things and you want to reduce all those to one value. That's the goal. So now let's look at method references. So do you have a break now or after?